To work molar coefficient relationships, we basically have to balance the equation first. So I'm going to take the hardest one on this sheet and balance it. So what you want to do is, when you balance chemical equations, is you want to basically list them. I list them below the yield sign. If I put it to the side, my brain goes, I don't know where the heck this is going. So basically, I list them below the yield sign. So we have carbon, we have hydrogen, we have oxygen. So, and we have 6 pieces of carbon on the reactant side. So this is the reactant side, and this is the product side. And we have 12 hydrogen. We also have 6 in the C6H12O6, which is glucose, plus the 2 in the individual oxygen, so that's a total of 8 on the reactant side. On the product side, we have 1 piece of carbon. We have 2 pieces of hydrogen, and we have 3 pieces of oxygen. 3, not O. 3. So the best thing you can do is leave this for last. Leave the simple ones for last. Try to balance the most complex. So we have C6H12O6. Again, that's glucose, which is simple sugar. There are different types of sugar, but this is simplest sugar in photosynthesis. This is respiration. So you eat that sugar, you breathe in oxygen, and then what's made is carbon dioxide and water. So what we can do is we have 6 pieces of carbon on the reactant side. So let's make 6 pieces of carbon on the product side. So now we have 6 pieces of carbon, and we have 6 times 2 for the oxygen is 12, plus 1 more is 13. So we have 13. 6 times 2 plus 1 more is 13. So my carbons are balanced, but my hydrogens are not. So to figure out to have the same number of hydrogens on both sides, we would have to multiply the 2 times a number to get 12. We know that 2 times 6 is 12. So we're going to put 6 in front of there. So now I have 12 pieces of hydrogen. And then there's a hidden 1. It's not listed, but there's a hidden 1. So 6 times 1 is 6 plus the 12. And so 6 times 1 and 6 in here. And then also 6 times 2, which is 12. So 12 plus 6 is 18. Now, I have my carbons are balanced, my hydrogens are balanced. I want to have the same number of oxygens on both sides. So I'm going to basically take, and I already have 6. I need 12 more. 6 minus 18 is 12. 18 is what I want here, and I want the same thing over here. So in order to do that, I have to put a 6 in front of here. Again, we wanted to leave the oxygen for last. Leave the simple numbers for last. It just makes your life so much easier. So 6 times 2 is 12, plus the 6 more over here, that's 18. So that gives me 18. So now I have 6 pieces of carbon on both the reactant and the product side, 12 pieces of hydrogen on the reactant and product side, and 18 on the reactant and product side. So my coefficient statement, there's also a hidden 1 here. A lot of times we forget that. But a hidden coefficient statement can say something to the effect of, for every 1 piece of C6H12O6 broken down, um, I will end up, we will end up with 6 pieces of carbon dioxide, CO2. So for every, now what you can do is expand that and say for every 1 mole of C6H12 broken down, we will end up with 6 moles of carbon dioxide. And that is a true coefficient statement using moles about essentially this chemical equation is for respiration, breathing in, um, and that is it.